Negative 5 and 12, there it is. So I'm going to put a minus 5x here and a 12x here. Most students who don't pass this class think they know why, but they're wrong. It's almost never the big scary topics. It's the ones that felt easy back in February, so they just didn't review them. So here are 55 questions to review an entire semester of content, section by section. There are 10 sections. Ready? Let's go. We're going to solve this system of equations by graphing. We're going to graph both of these lines on the same graph, and wherever they intersect, that is the solution. So the first line, y equals 1/2 x plus 3. The y-intercept is positive 3, so we are going to put a dot, a point right there on 3 on the y-axis. The slope is 1/2. It means you're going to go up 1 over 2, up 1 over 2, again, and you'd be pretty close to off the graph. So let's go backwards. Instead of up 1 over 2, we're going to go down 1 back up 2, down 1 back up 2, and see they stay in a line. So draw it. There we go. Let's graph the second one. If the y-intercept is negative 2, put a point there on the negative 2 on the y-axis. The slope is negative 3/4. I always put the negative on the numerator, so I'm going to go down 3 over 4, and I put my point there. Now I'm definitely out of graph here, so I got to do that one backwards. So that would be up 3 over 4, and I am right here. Draw that line. Your intersection point is your answer. So that point is negative 4, positive 1, and we're done. Each problem in every section has something different with it, a different twist, so you get a good overview. Now, when I look at these two problems, they both have the same slope of 3, but they've got different y-intercepts. The first one has a y-intercept of negative 4, and the slope is 3. That means you're going to go up 3 over 1, up 3 over 1, up 3 over 1. I probably didn't need 4 points, but when I'm doing solving by graphing, I graph as many points as I can. I want to make sure they're straight. The second one is plus 4 for the y-intercept. It has the same slope, but I'm not going to be able to go up 3 over 1, so I got to do it backwards. Down 3 over 1, down 3 over 1, down 3 over 1, and draw the line. But here's the thing. Those two lines have the same slope. That means they are parallel, which means there is no solution. You probably could answer that question without having to graph it, but if the problem is requiring you to do the graph, you should end up with two parallel lines. Now we're going to solve by substitution. Substitution is a technique where we take one equation that's solved for a variable, like this one is solved for y equals this thing, x plus 6, and you substitute it into the second equation. And here's what that's going to look like. Rewrite that second equation, but instead of writing 2y, I'm going to write 2 with a big hole next to it, and what goes in the hole is this x plus 6. Now we do distributive property. Negative 8x plus 2x plus 12 equals 0. When you combine the negative 8x with the 2x, you're going to get a negative 6x, so negative 6x plus 12 equals 0. I'm subtracting 12 from both sides, and I'll have negative 6x equals negative 12. Divide by negative 6, you get x equals 2. Be really careful. You're going to feel like you're done. But when you're solving a system, you need to solve for x and y. Right now, I only have the x. So to get the y, use the formula for y they gave you. We know that y equals x plus 6. So y equals, we know what x is. It's 2. So I'm going to pop that in right here. So y equals 8. Write your answer as an ordered pair. X equals 2, y equals 8, and you are done. We are still solving by substitution, but this is another twist. Neither one of the equations is solved for a variable. So you have to do that before you start. I always look for one that'll be easy, like there's just a single x here. I wouldn't have to do any dividing. I just have to move the negative 5y. So if I add 5y to both sides, I will end up with x equals positive 5y plus 19. Okay, now that is something I can use for substitution. I'll be taking this x and popping it into the first equation. Rewriting it, leaving a space, 5y plus 19 needs to go right here. Do distributive property. We end up with negative 40y minus 152 minus 2y equals 16. Always pause if you want to do the math along with me. I know I need to put the negative 40y with the negative 2y. That's going to be negative 42y minus 152 equals 16. Add 152 to both sides now. Negative 42y equals 168. Divide both sides by negative 42. And we end up with y equals negative 4. That's a lot of work. I know you feel done. You're not. You're only half done. We need to get the x. We have a formula for it right here. I know that the y is negative 4. So I end up with negative 20 plus 19. So my x is negative 1. Write that as an ordered pair. You would have x is negative 1, y is negative 4, and put a box around it. You are done. Sometimes you see problems like this where it's a system of equations, but they're both solved for y, so you don't know what to do. Well, if y equals two different things, it must mean these things are equal to each other. So that's the setup. Now you have an equation with a variable on both sides. I like to subtract the smaller one, so I end up with 4x minus 17 equals negative 5. Add 17 to both sides. We end up with 4x equals negative 5 plus 17 is 12. So x equals 3. Again, don't forget, you need to get a y. It doesn't matter which one you use. Just use the one that you like the best. So I'm going to use the one with the 3. So I'll put a 3 in here. Y equals 9 minus 5, so y equals 4. Rewrite that as an ordered pair and put a box around it. And for this one, it looks pretty straightforward, right? But I promise you, there's a twist here. And if you see this on an exam, I don't want you to get frozen up with it. So the y equals 2x plus 4, you start it the same way. We're going to put that 2x plus 4 into the second equation, do the distributive property, and we end up with some stuff starting to go wrong right now. You have a negative 6x and a positive 6x. So already you're like, I don't know about that. And then you get 12 equals 12. When this kind of a situation happens, it isn't like you did the math wrong. This is absolutely right. You just need to know how to interpret what you're looking at. This is something that is always true. This is an identity. When does that happen? Well, I'll show you what happened here. I'm going to take everything times 3. Y equals 2x plus 4. 3 times y is 3y. 3 times 2x is 6x. And 3 times 4 is 12. And now I'm going to subtract 6x from both sides. And look what I end up getting. Negative 6x plus 3y equals 12. And it's the same as this one. So what really happens here is when you get one of those identities going, they've given you a system that is actually the same line written twice. Just one of them was fiddled with to look a little different. So that means you have infinite solutions. No matter what you pick to put in for x, the y's are always going to work out to be the same. So put a box around that, and that's how you interpret it. All right, now we're going to solve each system by elimination. And here's a tip. If you're taking a multiple choice test, your teacher is not going to know whether you use substitution or elimination. If you are doing a written exam, that's why you have to know how to do each one of these methods. Elimination is where you try to eliminate one of the variables by combining these two equations. I call it smashing. If I smash these two together, adding up and down, negative 2x and a positive 2x are going to cancel out. So now we're down to one variable, which makes it easier to solve. A positive y and a negative 9y is a negative 8y. 2 and negative 18 is negative 16. We get to y equals a positive 2 right off the bat. Now you still have to find x. So pick your favorite one of these equations. I always try to do the one that doesn't have negative signs if I can help it. So 2x plus y equals 2. The y I know is also a 2. There's a lot of 2's. Subtract that 2 from both sides. We get 2x equals 0. So x equals 0. You're going to write that as an ordered pair. Put a box around it. You are done. Let's do this one by elimination as well. The thing is nothing is set up to cancel, but there is something you can play with if you make one little tweak here. If it had a minus 14x right here, I would be able to cancel those out. You don't have to always cancel the x's. You can also cancel the y's, but these two are both negative. They're not opposite in sign. I'm looking at this and I'm thinking if I multiplied everything by 2, and I do mean everything, including the 4 on the other side, then what I would have is something that's going to work. So I'm going to recopy that first one over here. Didn't do anything here. That's just this first one recopied. Now, the second one becomes negative 14x. 2 times 3 is negative 6y. 2 times 4 is 8. Now smash. Boom, they're gone. Put these together. You get a negative 14y equals negative 22, and 8 is a negative 14. So y equals 1. Pick your favorite. I like the first one. Leave a hole for the y. Put the 1 in there. And we're going to get 14x minus 8 equals negative 22. Negative 14x equals negative 14. I added 8 to both sides. So x equals negative 1. Write the ordered pair. Put a box around it. We're still supposed to use elimination here. I got nothing that's going to work. 2 and 3 are not easy. 4 and 3 are not easy. I'm still going to go for the x's, but the way you handle these is look for something that has opposite signs. I could go for the y's. I'm just using the x's because they're in front. If I multiply the top one by 3 and the bottom one by 2, I will end up with 6 x's, one negative and one positive, and they will smash and cancel each other out. So that's what I'm going to do. And then the bottom one times 2. So there's my positive 6x plus 8y equals 2 times 4 is 8. The most common mistake when people are doing things like this is they do not multiply the numbers that are on the other side of the equal sign. You've got to take everything times that number to keep that equality. Now we smash. Now I have negative 9y plus 8y. That's going to give me a negative 1y, and that equals negative 7. No, you don't have to write a negative 1y. You could just put negative y, but when I'm teaching, I always put the negative 1. So people will realize you have to divide by something. And that would be dividing by negative 1. And I end up with y equals 7. Half done. Pick your favorite. I'm going to go with the positive. I go back to the original for this. So for y, I'm going to use 7. Pop the 7 in there. Do the math. And now I'm going to subtract 28 from both sides. And I'm going to divide by 3. My ordered pair is negative 8, positive 7. Put a box on it. A system of inequalities is very similar to solving systems by graphing. We're still going to be looking for some intersection stuff, but it is a little different. When you are graphing an inequality, these symbols mean something as far as the kind of line you draw. This is a less than, which means when we draw the line, we won't draw a solid line. It's going to be a dashed line. And because y is less than, we are going to shade below. The symbol greater than or equal to means when you draw the line, it's going to be a solid line. And greater than means you are going to shade above. So let's look at the first line. The y-intercept is plus 2. The slope is negative 1/3, which means I'm going to go down 1 over 3, draw a point. And that's dashed. I strongly suggest you write this stuff out before you start graphing. This will help you to understand what you're going to do before you actually do it. So we need to be below, so we shade in this. Next one, the y-intercept is negative 1, and the slope of this one is negative 4/3. So I'm going to go down 4 over 3, drop a point there. I want a solid line, and that is above. Where these two regions overlap is your answer. So that's this little triangle piece right here. So there it is. That's the answer. If you pick any point that's in this area in the middle here, that where they overlap, that point will work and make both of these inequalities true at the same time. We have a less than or equal to on y with respect to 3. I know that that's going to be a solid line because that little equal to piece on the bottom of it. And I know I'm going to be shading below because it's less than. It is a horizontal line that goes through the y-intercept of 3. If we're going to shade below, this is pretty easy to see. Everything underneath that. Now for the second line, we have less than, which means that is a dashed, and it's still less than, so we're also below. Let's graph the line. The intercept is negative 3. The slope is 6, up 6 over 1. Draw the dashed line. Now to be below that, it's hard to see sometimes, especially if these are really steep lines. So look at the y-intercept. The y-intercept was negative 3. To get below that, you would be where negative 4 is and going down. So it's all this area here. So the part that works here is this one. These two lines have the same slope, so they're parallel, but let's see what's going on with the overlap. I've got a greater than or equal to sign, so I know it's solid, and I'm going to be shading above. The y-intercept is -1. The slope is 1, up 1 over 1. Solid line, shade above. The second line, same thing, greater than or equal to, so it's going to be solid and above. The y-intercept is different, so you're down here at -3, up 1 over 1, second point, solid line, shade above. Your answer to this system of inequalities is where they overlap. They only overlap in this region that is above the blue line, so that is what we shade in. So that last one was a little weird just because of the way they overlap. Let's see what twists I have here. I have a y greater than, not equal to, so it's a dashed line, and we're shading above. So the y-intercept is +3, the slope is 1, so it's up 1 over 1, draw the dashed line, shade above. This guy is less than or equal to, so that is a solid line, and we're shading below. The y-intercept is -3, slope is 1, shade below. Okay, there's the twist. There's no overlap. What does that mean? How do you interpret that? That means there's no point anywhere that will make these two inequalities true at the same time. If it was, they'd be overlapping somewhere in the middle, and they're not. So the answer to this one is no solution. If you don't know your exponent rules, here they are. When I look at this problem, x to the 4th times 4x squared, I am multiplying two things that have the same base but different exponents. That is the product rule. We're going to add the exponents. And we end up with 4x to the 6th. The 4 is just a constant, so it just gets carried along. And that's your answer. This is a power up. Everything in these parentheses is raised to the 4th power. But when we work with the a cubed, that's going to be a power rule, like this one right here. So here's how this works. The 3 gets the raised to the 4th power too, and then 3 times 4 is 12. People get these two rules mixed up. When it's a power up like this, you multiply your exponents. We go 3 to the 4th power, we're going to get 81 a to the 12th. Put a box on it. Looks like we got a division problem here, so we're going to use the quotient rule. First off, I see the same constant on the top and the bottom. I can just cancel those. And this x on the bottom, people forget, it has an exponent of 1. Just because you can't see it doesn't mean it's not there. So I really am doing x to the 4th divided by x to the 1st. And the quotient rule says you subtract the exponents if the bases are the same. So we get x cubed, and we're done. Things are getting a little trickier. I've got a negative exponent, but I'm going to not use this negative power rule right now because look at the product rule. The product rule says if the bases are the same, you add the exponents. This is a +3. So I can get away with doing this problem without having to think about, oh, you have to flip negatives and all of that. No. We're going to get that as an answer, and that's going to work beautifully. There'll be times when you have to use the negative power thing where you rewrite it as a fraction. This is not that time. I think this is going to be that time. All right, here come the rules. I have an x to the 0 power and I have a negative power. So I'm going to use both of these. Anything raised to the 0 power is 1. So that just pretty much goes away. So 4 times 1, and then I'm rewriting x to the -3rd as 1 over x to the +3rd. That's what you do when you have a negative exponent that you can't deal with any other way. Now when we multiply these out, we're going to end up with 4 over x cubed, and that's your final answer. Boy, this one uses all of them, which is why I kind of like this problem. So let's just see what we can get rid of first before we jump into it. And I also want to tell you there's more than one way to do these. So if you don't like what I'm doing, you would do something else. I get that. On a different day, I would do something else. Okay, first thing I did was cross out the 2's. Everything is being multiplied up in here. So these are all factors. Common factors can cancel. So 2's cancel. I'm going to cancel that x to the 0. Not because it turns into a 0, but because it turns into a 1, which means it makes no difference. So I rewrite what I have now. And what I did is I ran the 4th power through on here. So I have x to the 4th power, y to the 12th. The most common mistake here is that people will look at the exponents and not take the 4 and put it on the x as well. So now in the numerator, I'm going to try to combine what I can using this product rule. Same base, you add the exponents. So I have x to the 4th times x to the 4th would be x to the 8th, y to the 12th times y to the negative 4th. I don't need to rewrite that as a fraction because if I add those together, I still end up with a positive 8 as an exponent. On the bottom, just recopied it. Okay, now deal with the x's separately and the y's separately. I have x to the 8 minus 1 because 1x has an exponent of 1. And y to the 8 minus a negative 1. Be real careful here. You can see a sign mistake could happen. And then I write the final answer. X to the 7th, y to the 9th, put a box on it, and you just finished that problem. If you did that by yourself, congrats. I like to set these things up vertically, especially with all these different terms in here. So I'll copy the first term, and then I'm going to add this to it, but I'm going to line things up and down. So I have 7 n to the 4th that I'm going to put underneath 4 n to the 4th. I see the plus n, I'm going to line that up underneath my negative 3n, and then my n squared goes there. It's just personal preference here. I tend to make fewer mistakes when I do this vertically. So I have 11 n to the 4th minus 9n squared minus 2n. Put a box on it. Now subtraction is going to be a little bit trickier. And both of these are all mixed up. All right, let's look at this first polynomial. I have a constant, I have an x term, and I have an x cubed term. What I don't have is an x squared term, which wouldn't be a problem except this one does have an x squared term. So I'm going to rewrite the first polynomial in order. The highest exponent goes first. I don't have his x squared term, so I'm going to put a placeholder there, 0x squared. That comes in really handy in other situations too, so don't forget that you saw that. Then you have the 5x, and then you have the 6. Now, this minus changes the signs of everything in the parentheses. So when I recopy this, I'm going to change the signs. We're starting with a minus 6x. I'm going to put that underneath the 5x. Then I have a minus 3 that I'm going to put underneath the plus 6. And I have a minus 8 squared, which I'm putting under this placeholder, which is why I did it. Add downward, and you're going to get x cubed minus 8x squared. A positive 5x and a minus 6x is a negative 1x, and 6 minus 3 is 3. Put a box on it. Most teachers teach FOIL, first, outer, inner, last. You multiply the first terms together. 6r times 3r is 18r squared. Outer would be the 6r times the negative 7. That is a negative 42r. I stands for inner. Negative 5 times 3r would be negative 15r. And L stands for last. Negative 5 times negative 7 is a positive 35. Now, the middle terms need to be combined because there are like terms with the r there. So it's r squared minus 57r plus 35. That is the correct answer. I did it like this for years. And then I started using the box method when I taught. I have 3r times 6r, that's 18r squared. 3r times negative 5 is negative 15r. Negative 7 times 6r is still negative 42r. Negative 7 times negative 5 is a positive 35. You are going to have to still add these boxes that have the r's in them, but you're going to end up with the same answer. Now this is personal preference. I like the boxes more for this because they help a lot when we get to factoring. But the answer is still that. All right, here's the first little twist. What if they're the same? 5v minus 8, 5v plus 8, except those signs are different. What happens? 5v times 5v is 25v squared. Now 5v times negative 8 is negative 40v. Positive 8 times 5v is positive 40v. And then negative 8 times a positive 8 is negative 64. What happens with everything being the same but the signs being different is you end up with these middle terms that cancel out. So you get something that we call the difference of two perfect squares. You'll see this again when we have to do factoring. Factoring would be to start with the answer and go back to the problem. For right now, you're just multiplying, and that's what you get. This question isn't supposed to be tricky, but it will do this all the time. They take this shortcut because they learned this when you did your exponents. They think this squared goes on all the terms on the inside. That would be true if you were multiplying them. It is not true if you're adding. Just do the problem. It's 6x plus 5 times 6x plus 5. 36x squared, 30x, another 30x, and 25. And the right answer has a middle term in it. This is it right here. Okay, this one looks tricky. Here's how you'll set up your boxes to do it. You have 2 boxes by 3 boxes because this is 2 terms being multiplied times 3 terms. So just fill in all the stuff. This 3x squared goes here. This will be the 2xy, and this will be the 2y squared. 6x here, y there. And now you just do what we've been doing. 6x times 3x squared is 18x cubed. 6x times 2xy is 12x squared y. 6x times 2y squared is 12xy squared. Y times 3x squared is 3x squared y. Y times 2xy is 2x squared y. And y times 2y squared is 2y cubed. Now we just write out the answer. We start with the x cubed term, so we have 18x cubed. Now this 12x squared needs to be combined with this 3x squared y. Those two are going to get added together as well. So we're getting 15x squared y plus 14xy squared plus the 2y cubed. That's your answer. Put a box on it. Factoring is like doing what we just did, but backwards. We're going to start with something that's an answer, and we want to find out what did they multiply together to get this. So when you look at both of these terms, the idea is what can be divided out of both of them. One of the things can be a 5. I can take a 5 out of a 5 and a 35, and an x, because this is x squared and that's just an x. So I'll write 5x, and then I'll put some parentheses and figure, okay, what do I have to put in the parentheses to make this work? 5x times something equals 5x squared, that is x. 5x plus 7 gets you the 35x, and that is the answer. But you want to do a check if you're not sure. Do distributive property back, and there it is. So that is our answer. So look at all 3 of these terms. They all can be divided by something. You should always start by looking at that to see if there's something you can pull out. And I can see I can take a 6 out of all of them. To do this, you have to factor x squared plus 10x plus 9. I like to do this with boxes. There's more than one way to do it. A lot of people do guess and check. I like the boxes because at least it gives you something to organize your work. We used boxes before and we put the numbers up here and then we would multiply to fill out the boxes. This time we're doing that backwards. I'm going to put the x squared here because remember this is the answer we're trying to get to. The 9 will go in this box. Now the interesting part is we don't know what's going to go in these 2 boxes. The only thing we know is that whatever was in those 2 boxes combines to be a 10x. What I want you to do is multiply the coefficient in front of the x squared. In this case, it's just a 1 because it's only an x squared. Multiply that times the last number, constant, which is 9. We are looking for factors of 9 that add up to 10. Well, it's this one, 1 and 9. 3 times 3 equals 9, but 3 plus 3 equals 6. So that's not going to get us the 10. We need this pair. The 1x goes here, and the 9x goes there. Once you have this filled out, now you start factoring out from the lines. What goes into an x squared and an x? That's just an x. What goes into a 9x and a 9? That would be a 9. Now factor up. What goes into x squared and 9x? That would be x. And what can you factor out of an 1x and a 9? You might think like that's nothing, but that just means you can take out a 1. Now double check. Make sure everything's working the way it's supposed to. X times x is x squared. X times 1 is 1x. 9 times x is 9x. And 9 times 1 is 9. So that means the x plus 1 times x plus 9 is the factored form of this, and you still had the 6 out in front. Look at all 3 terms. There's nothing you can pull out that goes into all of them. The 7 is the one that's kind of messing things up. So let's go right for the box. The first term goes in the first box. The last term with its sign goes in the last box. We do not know what these are going to be, but we do know that once we figure it out, they have to combine to be a 7. To get started with that, take the coefficient in front of the first x squared term times the constant. 2 times negative 30 is negative 60. I'm using that negative 60 to come up with numbers that when I multiply them together are equal to negative 60, but when I combine them will be a positive 7. Since this is negative, I know one of the numbers is negative and one is positive, so I'm just going to start listing numbers, and I always start with 1 because people will forget that. 2 and 30 make a negative 60, but when you combine them, you get a 28. Negative 4 and 15, that gets 11. We are getting close. Negative 5 and 12, there it is. So I'm going to put a minus 5x here and a 12x here. And these can be flipped. It doesn't matter. It'll work. Now, let's pull things out that go into both. 2x squared and a minus 5x. The only thing that goes into both of those is an x. 12x minus 30. What can I divide out of both of those? The biggest number would be a 6. You want to try to get the largest one. But what do I multiply times x to get a 2x squared? That would be 2x. Does 2x times 6 give you 12x? Yes, that's your check. What do you multiply times x to get a minus 5x? Negative 5. And does negative 5 times positive 6 equal negative 30? Yes. So these are the factors of this trinomial. 2x minus 5 and x plus 6. You can go to boxes for this one if you want. I'm looking at this 25x squared and I'm looking at this 16 and I'm like, I don't even want to multiply those two together and use boxes. You can, but I also want to point something out. This looks kind of familiar to me. This looks like 5x squared and this looks like 4 squared. What if this is really 5x plus 4 times 5x plus 4? What if these are the factors of this thing? Well, let's check it with the boxes. Instead of factoring, now I'm just multiplying. So we get the 25x squared there, which is what we expected, and we get the 16 there, which is what we expected. But what do we get in these other two boxes? 5x times 4 is 20x, and 5x times 4 is still 20x. And when you add those two together, that's your 40x. Boom! We did that with guess and check, but with a little bit of checking with the boxes. It's cool. That's the answer. All right, here's another twisty one. How do you factor something like this? Especially if you just want to have one way of doing everything and don't want to do a lot of memorizing. Well, the 4x squared goes here, and there is no middle term. You just have the constant term, which would go in this box. So if you have no middle term, use that placeholder idea again. We need two numbers that when you multiply them are going to give you 4 times negative 25 would be negative 100. But when you combine them, they're going to end up being a 0x. So let's run our list. Negative 1 times 100 is 99. Negative 2 times 50 is 48. And I know you probably have already figured this out. Whatever the numbers are, they have to be the same. So it's got to be negative 10 and 10. That's the only way you get a 0. So negative 10x and 10x. Now we factor. We can take a 2 out of a 4. We can take a 2 out of a negative 10 as well, but also the x's. And what can I take out of both of these? A 5. And up on the top, we're going to take out a 2x because 2x times 2x is 4x squared. And what do you multiply times 2x to get a negative 10x? That would be negative 5. And negative 5 times positive 5 is negative 25. So this was the difference of two perfect squares. We talked about that in the last section where I was doing multiplication. But if you forget how that works, this is how you're going to figure it out using your boxes. Okay, to solve this equation, you need to isolate that variable. So just like any other equation, add 10 to both sides. We get 6b squared equals 54. Divide both sides by 6. b squared equals 9. Now take the square root of both sides. And don't forget, there's two ways to get a 9, 3 squared and negative 3 squared. Now for this one, we're going to take the square root of both sides. And we end up with x minus 3 equals plus or minus 4. Don't drop your plus or minus, because that's how you're going to get two answers here. And we're going to set up two little equations. One where x minus 3 equals positive 4, and another one where x minus 3 equals negative 4. Add 3 to both sides. We're going to get 7, because 4 plus 3 is 7. Add 3 to both sides, and we are going to get negative 1. And those are your two solutions. Okay, now we have to solve by factoring. You want to make sure you always have a 0 over here. And then we are going to factor this thing. We know we need an n, because that's an n squared. N times n is n squared. And I know to get a 15, I need two numbers that multiply together to get a 15, but I have to get a 2 in the middle. So it has to be numbers that are like 2 apart. This is a negative 15, which means one of my numbers is negative and one is positive. Now that you have this thing factored, set equal to 0, it means one of those is equal to 0, using the zero product property. Now subtract 5 from both sides, we get n equals negative 5. Add 3 to both sides, we get n equals 3, and those are our two answers. Now we need to do factoring again. This one's not going to be quite so easy to do just off the top of my head, so I'll bring the boxes back in. Remember, we put the first term in the first box. We put the last term in the last box. We don't know what these boxes are right here, but we do know that when you put them together, you're supposed to get a positive 17. The target number we're looking for is 2 times 30, that's 60. 1 times 60, 61. 2 times 30. When I combine them, I get a 32. I'm wondering if you're catching my pattern here. Doing it like this, I don't have to just think of numbers off the top of my head. I'm just running through the list, starting with 1, then 2. 3 goes into 60. 3 plus 20 is 23. 4 goes into 60. 4 and 15 makes a 60, but when you add them, you get a 19. We're getting closer. There's the 5 and the 12. There's our 17. We used that one before. The 5m goes here. The 12m goes there. Now to factor. Taking out from a 2m squared and a 5m, I can take out an m. A 12m and 30, the largest thing I can take out is a 6. What do you multiply times m to get a 2m squared? That would be 2m. What do you multiply times to get the 5m? That would be a plus 5. Double check. 2m times 6 is 12m, and 5 times 6 is 30. So these are the factors. That would be 2m plus 5 and m plus 6. Feels like we're done, but this isn't a factoring problem. We are solving. So each one of these needs to be set equal to 0. Subtract 5 here. Now divide by 2. So one of the answers is negative 5 halves. And subtract 6. And there's the other one. We're going to do the same thing, but the twist with this one is that this is not a 0. So I have to subtract that from both sides first. And I end up with v squared minus 4v minus 12 equals 0. I'm going to try factoring that in my head. I know I need a v and a v. That's how you get the v squared. 12. I need it multiply to be 12, but are like 4 apart. So this would be 6 and 2. Since this is negative and this is negative, I know the larger number is negative and the smaller number is positive. And you can always multiply through and see if this works. And if it doesn't work, make adjustments. So v plus 2 equals 0, or v minus 6 equals 0, which means v equals negative 2, or it equals 6. Quadratic formula. There it is. Negative b plus or minus the square root of b squared minus 4ac over 2a. The a, b, and c come from the coefficients in front of the terms. So I'm going to substitute those all in. Their signs go with them. And now let's just start working the math here. Simplifying what I can. 8 squared is 64. Negative 4 times 1 times a negative 15 is a plus 60. And 2 times 1 is 2. Keep going. This one is a paper hog. I got a square root of 124 here. You have to play around with that. This is a radical and you want to simplify this square. So I checked to see if 4 would go into it because 4 is 2 squared. And it does. It's 4 times 31. The square root of 4 is 2, and that's why there's a 2 on the outside. So we have 8. Whoa, I made a mistake. That's supposed to be negative 8. Okay, this looks weird, but I just went in and added all my negatives. You'll see in a sec. It's a long video. It's not worth redoing the whole thing. You'll follow me. And dropping a sign is actually a really common mistake, so I'm glad I did that so you can see it. I make dumb human mistakes too. So here's what I did at this point. We have the negative 8 plus or minus 2 square root of 31 over 2. Then I broke that up into 2 fractions. The negative 8 gets divided by this 2, plus or minus, and then this little radical thing divided by that 2. And then negative 8 divided by 2 is a negative 4, plus or minus, and then the 2's cancel off of that one, and that's your answer. Sorry about the mistake, but I'd rather I make them than you make them, because you're getting graded. Solve by completing this square. I want to bring back this question we just did, which is question number 32. If you remember, this was pretty easy. The reason that worked so slick was because we had this x minus 3 quantity squared. If we can rewrite this thing to look like that, we're going to solve it like this and it'll be really easy. So here's how you do that. We're going to start by doing something kind of a little backwards. You'd normally think you want a 0 here, but for completing the square, we want to keep these variables over on one side and move all the numbers to the other side. So now we have n squared plus 14n, and I want you to put a space here, plus something else equals 15, and whatever we add here, we're going to add to this side. Now, what do you add here? Remember, we're trying to complete the square. We want this to be something squared. So you take the middle number, divide it by 2, and that's 7, and then you square that. And that's the number you put here. And to keep the equation balanced, we have to put it on this side as well. Now that's what we have. Well, n squared plus 14n plus 49, this can be rewritten. It is n plus 7 squared. And that equals 15 plus 49, which is 64. And that's called completing the square. N plus 7 equals plus or minus 8. So n plus 7 either equals a positive 8 or it equals a negative 8. This first one, subtract 7 from both sides. In your head, you get n equals 1. Subtract 7 from both sides, n equals negative 15. These are your two answers. Sketch the graph of each function, identify the vertex, the axis of symmetry, and the roots. This is a quadratic function, you can tell because there's a square there, so we're going to use something called the HK form. It's already in that form. The A is what's the number up in the front. The A is usually telling, right here it's a 1. I know you can't see it, it's invisible. A tells you whether the thing is opening up or opening down. The vertex of this, it's going to be a parabola. The vertex of the parabola is HK, which is a little tricky because the H has got a negative in the formula, so we've got some sign flopping going on there. K just is whatever it is because there's a plus in the formula. All right, so the vertex being HK, how do you figure out the sign of that H? Well, your formula, just the template of the formula, has the x minus in it. So it's whatever you stick in here that's going to turn that thing into a plus 3. That has to be a negative 3 here because subtracting a negative 3 is the same thing as adding a 3. And if this is a minus 1 in the back, it means our k was also negative 1. So the vertex is negative 3, negative 1. That was one of the things we were supposed to find. So let's graph it because we have to do that too. X is negative 3, y is negative 1, so it's this point right here. I know this is going to be opening up because the 1 is positive. What I don't know is where it's going to intersect with any other points. We'll get to that in a second. It's asking us also for the axis of symmetry. This is pretty easy. You don't even need to see the parabola to get it because the axis of symmetry is always the line that is vertical going through that vertex, which means it's going through -3. It means the axis of symmetry is the equation x equals -3. So those are two of the answers. We also have to find roots. The roots are when y equals 0. The roots are where it crosses right here. Somebody else might say the answers. So you want to find the answers when you let y equal 0. Well, we've already been doing these problems. We're going to add that 1 to both sides. Then you take the square root of both sides. And we end up with x plus 3 equals plus or minus 1. We know that our roots, there's going to be 2 of them. That's what the plus minus gives you. One of them is going to be -3 plus 1. The other one is going to be -3 minus 1. So those two answers are -2 and -4. But as points, remember the y is 0. You write them as -2, 0, -4, 0, and that's actually what you plot. So the -2, 0 is here, the -4, 0 is there, and now you have enough to draw a parabola. That's the full answer. I have my roots, I had the vertex, the axis of symmetry, and that's what the picture looks like. All right, look at this one. Again, let's look at the HK formula again. In order for this to be positive, it's like that last one. The h must have started out to be -5, because then you would have a -5. So the vertex is -5, -2. So we plot that point, -5, -2. Now the axis of symmetry is the line that goes through that, which is going to be x equals -5. I know my a is -1, which means from this vertex, my parabola has to open down. Oh, okay. Well, so here we have a problem. This parabola opening down doesn't go anywhere up towards the x-axis, so that means there are no roots. There's nothing, this thing's not crossing here. So it's actually no real roots. But in Algebra 1, say no roots, it's probably going to be okay. When you get to Algebra 2, we're going to talk about something called imaginary numbers. And no, that doesn't mean you're making them up. But there's no real roots. There's no real solutions here. So that's your vertex and axis of symmetry, and you have no real roots. You want to take that number and break it up. So you got at least one perfect square underneath there. And then you have square root of 4 times the square root of 7v. I kept those two together because that 7's not a perfect square. 2 times the square root of 7v. And that is your answer. You do need to know your perfect squares up to a certain point to make this go a little easier. All right, number 41. The -2 is on the outside. We got to deal with what's on the inside. So I have a 32. Let's pretend you don't know your perfect squares. Or you just blanked out because this is a final exam and you're freaking out. You might make something like this called a factor tree. And once you've got everything factored down, you can see, you could have stopped at any point to see what's going on. But if you go all the way to the bottom, I actually have 1, 2, 3, 4 2's down here. Well, that would mean there's a 16. 2 times 2 times 2 times 2 is 16. And what's left over is a 2. So I'm going to bust this up into 16 times 2. I could have used a 4, sure, but then I would have been left with an 8, and then you would have had to do it again. The 16 is the largest perfect square that goes into 32. Now, once I have everything broken up into perfect squares, and what you didn't see me do, or maybe you did, but I didn't talk about it, is that this p to the 4th is actually p squared times p squared. So those two perfect squares there. So whether you write it out or do it in your head, you're busting everything into separate square root problems. Then you write in the answers. 16 turns into a 4. Root 2 stays the same. P squared. Root p squared is p. Root p squared is still p. Then all of these not radicals go up in the front and get multiplied together. -2 times 4 is -8. P times p is p squared. That's your answer. We're going to bust it up again here. So the 6 is from the outside. Put the x squared under its own radical, and I kept y cubed under its own radical, although I'm going to rewrite that right now. So that's y squared times y. Bust those up. I end up with 6 times 10 is 60. The x is still there. Put the y squared under its own radical. Put the y under its own radical. Simplify that y squared one. and we are done. More than one way to do these, guys. So I'm looking at this and I'm thinking I can add things together that have the same radical. I know the square root of 18 is not simplified. If you see that, I know that, but I'm going to make that into one term before I start playing with it. So if I have 3 of those cookies here and I add 3 more cookies, I have 6 cookies. So it's -3 square root 2, just copied 6 of those little cookies that have the square root of 18 on top of them because I'm a math teacher. All right, we got to bust this one up. Hopefully you're going to turn it into something that has a root 2 so we can combine these. Well, we'll see. I'm recopying the first one, and I'm changing 18 to 9 times 2 because 9 is the largest perfect square that goes into 18. Break that into 2 square roots and simplify that one. We end up with 3 square root of 2, which we've been just carrying along like a backpack. We have -3 root 2 plus 18 root 2. Very good. Now we can add them together because these match. It's like you have the same kind of cookie. -3 and 18 is 15, and we are done. This one is a little bit different. Look at it too fast. It's going to seem like it's a subtraction problem, but there's a little multiplication right there. When you are multiplying 2 radicals together that are the same kind of radical, like these are both square roots, if they're separate, you can put them together. We've been doing that. We've been just using it backwards where we bust them apart. But now we're going to put them together and see if we can simplify this a little bit before we do anything else. Doing each one separate feels like it would be twice the work for me. Here's my 15, there's the a, there's the 20, there's the a cubed. Okay, what can I do with all this stuff? I think all of these can be busted up into their factors. So 15 is 3 times 5. A just comes along for the ride. 20 is 4 times 5. I'm not going to break that down any farther because 4 is a perfect square. And a cubed is a squared times a. So look, I have 2 5s right there. I have 2 a's right there. I have a 4, and I have an a squared. Now, depending on your comfort level, some people are just going to pull all those out, but those are all perfect squares. Let me show you. 5 times 5 is 25. 4, well, is 4. A squared gets its own radical, but there's another a squared here because there's 2 a's being multiplied there, so that's the second a squared. And 3 doesn't have a partner, so it's all by itself under its own radical. Now, let's simplify everything that can be square rooted. We get 3 times 5 times 2 times, whoa, mistake. What did I do wrong? I'm not going to fix it right now. Can you catch the mistake? I'm going to continue it. But what mistake did I make going from here to here because I was in a hurry to finish this video? Yeah, I know you can see it. And we're going to get that for the final answer. I'm going to put a box around it, and when my teacher sees that, I'm going to get either the whole thing wrong or some partial credit removed. What was the mistake? You can tell me in the comments right now. I hope you got it. This looks complicated. We're still working with radicals here, but I want to write a simpler problem, and this is a technique I learned as a student and passed it along to my students, so that if you see a problem you're not quite sure what you're doing, and if you're on number 45, you're kind of at the end of your final, you're probably tired, write a simpler question. You would do distributive property on this. So that's what you're going to do with this. And let's rewrite it. Root 3x times 5 plus root 3x times root 6x. This, I'm just going to rewrite it with the 5 in the front, but these two I can combine under one radical and see what I've got to work with. Ooh, we've already busted that 18 up once in a problem just before, which is also another thing, a tip for a final exam. Stuff sometimes repeats itself, and so if you solved it before or you did a piece of it before, you might go back and look at what you did. So 18 is 9 times 2. Now we're going to break these up into separate square root problems. And the 5 root 3x is just kind of coming along again like little brother or sister following you around at the mall. All right, square root of 9, square root of 2, square root of x squared. Let's hope I don't do that same dumb mistake again. The square root of x squared is x. Good job, Does Math for Coffee. All right, what do we got here? Oh, yeah, this x isn't underneath the radical, so it's got to come in front with the 3. And this is as far as you can go, and be real careful. This question looks like it's trying to trick you into going one more line, thinking you can do any combining with this 3x and that 3x. This is the square root of 3x. That's like saying that the square root of 7 is the same thing as the number 7. It's not. You cannot combine unless the radicals match. The cookies have to be the same flavor. Well, I'm looking at this. The first thing I notice is that square root of 16 is just a fancy way of writing the number 4. The square root of 20 is 5 times 4. So let me rewrite what I'm looking at. Oh, that's kind of pretty, but you need to be really careful. Here's a piece of scratch paper. I know somebody is going to see a problem like this, and I know they're going to do this. I would bet money that there'll be an algebra student somewhere that's going to cancel the 5 times 4s and get 1 over square root of 1 and tell me that the answer is 1. No, this is not correct. No way. Screenshot that if you think that would be one of your mistakes you'd make when you're really tired and you want to get done and go to lunch. So let's just keep working what we have here. 5 times 4 is 20. That's on the top. And on the bottom, I could multiply those out, but since they're already broken up into factors, I'm going to write them as 2 separate square roots. So we end up with 20 over root 5 times 2. And I'm looking now at the 20 and the 2. And I know I can do a division with those because 20 divided by 2 is 10. That would be my new numerator. And my denominator is the square root of 5. This is a nice answer, but you can't have a radical in the denominator. So you're going to need to do something with that. And the thing you have to do is rationalize the denominator. Rationalizing the denominator for this one, we're going to take the top and the bottom times the exact same thing. Even if it looks complicated, the same number divided by itself is 1, so you're not changing the value. Multiplying straight across, we end up with 10 times root 5 over root 5 times root 5, which is root 25. Root 25 turns into 5. Pretty sweet, huh? It's a trick to get the radical out of the denominator. And now you have 10 over 5 times the square root of 5. So your final answer is 2 square root 5. 10 divided by root 5 is accurate. It's just not in good form. It's a math grammar thing. This is the right answer that would be on the answer key. Remember, don't do that. For this one, we have to start with rationalizing. There's nothing else I can do with simplifying like that last one. So we're going to do root 5 over root 5 again. You don't need to worry about rationalizing the numerator. You're just always rationalizing denominators, whatever that number is. So on the top, I have 5 times root 3 times root 5. And on the bottom, I have 4 times root 5 times root 5, which means I have 5 times root 15. Multiply those two together. And then I have 4 times, this is 5. Root 5 times root 5 is just 5. Remember, it turns out to be root 25, and root 25 equals 5. I just skipped a step right there because we just did it. Now these 5s are going to cancel each other out, and what you're left with is root 15 over 4. There's nothing more to do here. You can't break that root 15 down and do any more canceling, so put a box on it. Okay, number 48. It's a little bit iffy whether your algebra teacher covered this or not. I'm putting it in here just in case, especially if somebody's in an honors algebra one. Well, you're going to still do the rationalizing the denominator, but this time you multiply it by something called the conjugate. This is what I want you to remember. We already talked about this. When you take a plus b times a minus b, you get the difference of two perfect squares. So if I do this little trick here, where I multiply negative 2 plus square root of 2 times negative 2 minus square root of 2, they're exactly the same except I change the signs. I'm going to be able to use this rule for that difference of two perfect squares. Whatever I do on the bottom, I have to do on the top as well. So that's the thing to do. Exactly the same, change the signs. Now when we multiply this out, the top will become 3 times the quantity, negative 2 minus root 2. And on the bottom, you're just going to square each one of these terms. So it'd be negative 2 squared minus square root of 2 squared. So the top is going to become 3 times negative 2 is negative 6. 3 times negative root 2 is negative 3 root 2. And then on the bottom, negative 2 squared is a positive 4. And root 2 squared is just 2. So this turns into 4 minus 2. So this trick right here, rationalizing with this thing where the signs are opposite, clears the radicals from the denominator. We have -6 minus 3 root 2 over 4 minus 2 is 2. If there was anything more to be canceled, you would, but you can't. So you put a box on it and you are done. All right, we are solving this equation. You have to isolate the radical. Subtract 6 from both sides so the radical is all by itself. 9 minus 6 is 3. Now you need to square both sides. When you square a square root, you just get what was on the inside. Isn't that nice? That's so slick. And 3 squared is 9. I subtracted 4 from 9 to get a positive 5, but it left me with a minus x. Don't just drop the minus sign. That minus goes with the x. So if a negative x equals positive 5, a positive x equals negative 5. Do a quick mental check right now. If you can put a negative 5 in here and not get anything blowing up, 4 minus a negative 5 is the same thing as 4 plus 5. You can totally do that. You can take the square root of a 9. It works. Put a box on it. 50. We have radicals on both sides, nothing else going on, so I'm going to square both sides. And when I square this side, I get -1 minus 6x, and this side would just be x plus 6. And then all of a sudden, this is just a regular equation with variable on both sides. A little tricky because of the negatives. I end up with -1 equals 7x plus 6. Now I'm going to subtract the 6 from both sides. -7 equals 7x. So I divide both sides by 7. X equals -1. Last section, hang in there, we're almost finished. Simplify each and state the excluded values. Excluded values are numbers that you can't use for a because it'll make a 0 happen in this denominator, and then, bad things happen, worlds implode, stuff like that. So let's simplify by factoring first. Let's break everything up into its factors and see if there's anything we can cancel. So 3 times 8 is 24 times a, and I got 3a on the bottom, and then a minus 6. Okay, now, here's a tip from me after doing this forever. I stop right now and do those excluded values right now. You don't do them after you've canceled stuff, because I know you're itching to cancel the 3 and the a, but you'll miss an excluded value. Excluded values mean nothing can equal 0 in the denominator, so 3a can't equal 0, and a minus 6 can't equal 0, because if either one of them did, we get the 0 in the denominator, and, planets collide. So I know that if 3a can't be 0, then a can equal 0 itself, because 0 times 3 is the only way that turns into a 0. And this one, just solve it. Add 6 to both sides, and we say a can't equal 6. So you're already done with that excluded value part before you do any more work. Isn't that sweet? You don't have to go back and do it. Just get it done right away. Now, cancel. Oh, it's just so fun. All right, we get 8 over a minus 6. There's nothing else you can do. That's totally simplified. Let's do it again. Now remember, these are the steps. Factor first, then you do your excluded values, and then you do your canceling. So factoring the numerator, I can take a 7x out of both of these. And for the denominator, forgive me if I just went ahead and did it for you. We've already talked about factoring in this video quite a bit, so I just went ahead and did it. When you do this correctly, something should cancel. If you make a mistake factoring and nothing cancels, that's a big hint to go back and look for a mistake there, because stuff is supposed to cancel if it's on a test. So let's get our excluded values next. X minus 8 can't equal 0, and x minus 10 can't equal 0. This is just like solving with this just little language change where you're saying, I don't want that to happen. So x can't equal 8, and x can't equal 10. You're done with that. Now scratch. Oh, scratch that itch. 7x over x minus 8, and we are done. Simplify each expression. It's multiplication. So we're multiplying straight across. I need to factor this, and I need to factor that a little bit. I can pull a 2 out of there. I think I can pull a 2 out of this one as well. So I do my factoring. Now, can I do any canceling? I probably need to factor this thing, because right now it doesn't look like anything's going to cancel except the 2, but that's not really super satisfying. But this isn't completely factored either. So if you want to do it yourself, pause, because I'm about to do it for you. There it is. And of course, that takes a little more time than me just clicking a mouse button, but yeah. But now we can see there's something in there. So I know I can cancel those 2's, but I can also cancel the x minus 4's. Right, what's left and see if there's anything else you can do with it. And I can't. This is all completely in factored form. Don't you dare touch those x's. They're not factors. The x minus 5 is a factor. The x plus 7 is a factor. The x minus 9 is a factor. They are groups. You can't just pick x's out of there. Put a box on it. You are done. Rationals are just fractions. They're algebra fractions. The thing is you probably would want to go for a common denominator here. I don't know if you ever remembered like this little, what do they call it? The butterfly? I don't know what they're called. I'm a high school teacher. But this is what I know. If I'm adding two fractions that have different denominators, you can get away with doing it like this. Take this numerator times that denominator, take that plus, put it here in the middle. Now take this numerator times that denominator, and then the bottom are those two things multiplied together. That is finding a common denominator, but doing it in one step and not making it seem terribly complicated. If you remember what that's called from middle school, drop it in the comments so I can remember. I just remember how to do it. I don't remember what they call it. Now I'm going to do distributive property for these guys. I'm going to take the 6 times the x, the 6 times the -3, the 5 is going to get run through as well. I am not multiplying the denominators. I'm still going to hope that something will get canceled once I put all those numerator things together. Okay, that's a big tip. Do not do that work. That will be a waste of time. This part's already done unless we get to a point where we can cancel something. Now, let's put like terms together. The 6x has to go with the 15x, and the -18 has to go with the -25. Again, I did that for you. Sorry. You got to pause faster. Okay, now, there's absolutely nothing I can do with the 20x minus 43. They don't have common factors, and they certainly don't have common factors that look like any in the denominator that I can cancel. So, yay, we're done. Put a box on it. Last question, and looks like a doozy, except if you look at it carefully, on this side where there's a subtraction, these denominators match. Oh, that's a gift. So in the next line, I am going to put the numerators together with a subtraction in between. I'm going to factor this trinomial, and then I'm going to set it equal to 1 over p minus 4. Pause right now if you don't want me to wreck it for you. Okay, here it comes. P minus 1 minus 6p plus 36 all over p minus 4 times p minus 6 minus equals 1 over p minus 4. There's no canceling yet. This is an equation. Be careful. But I do want to have a common denominator here. Like, I know I can cross multiply, and maybe that would be cool. But I have a feeling this is going to work better if I just do something like this. If I take this times p minus 6 over p minus 6, this is just a really fancy 1. But now I have a common denominator, p minus 4, p minus 6 equals p minus 4, p minus 6, which means my numerators have to be equal to each other. I can get rid of the fractions right now. As soon as the denominators match on both sides, the relationship is with the numerators. So now I have p plus 1 minus the quantity 6p plus 36 equals 1 times p minus 6. No more fractions. So now let's work with this. Big mistake can happen right here. Remember, this is the last question on somebody's test somewhere. So they're tired and they are going to make a sign mistake right here. When you are subtracting a quantity, everything inside gets its sign changed. So p plus 1 is going to come down, but this will be negative 6p minus 36 equals p minus 6. So now we're just going to combine like terms. I have a p and a minus 6p, a 1 and a negative 36. So that's going to get me negative 5p minus 35 equals p minus 6. Add it to both sides, get that cleared out. So I have negative 35 equals 6p minus 6. add 6 to both sides. I'm getting 29 equals 6p, and then you divide both sides by 6, and can't lie, I would be a little suspicious of an answer like this, so I would go back and check all my steps. But that is the correct answer, so put a box on it. Hey, this was a long review. Thank you for hanging in there with me, and I would love to hear how your algebra final went for you this semester. See you next time. Bye.